Good morning, everyone. My name is Shahin Hallaj. I am a postdoctoral researcher at the University of California, San Diego. And I'm excited to talk with you about the work that we've been pushing forward at the eye care subgroup and the glaucoma subgroup of Odyssey. And that is around representing ophthalmic visual field perimetry data in OMOP CDM. I have no financial disclosures, just a little bit of introduction about the perimetry itself. It's one of the main tests that is being done in ophthalmology clinics, and what it does is that we have a patient that puts their chin on a chin rest over here and fixates on a single point, and different stimuli will be presented to the patient, and if they see it, they will click on a button, and it will give us a beautiful map like this that will basically show us where the visual defect is. And what the actual report looks like, you can see in this slide that we have so many data elements that are very important to the clinical decision making, and people are using it in glaucoma clinics and ophthalmology clinics, and sometimes neurology clinics. So the whole idea is that we want this very important data element and this very important modality to be represented in OMOP CDM to be able to use it for outcomes research in glaucoma care and neuro-ophthalmology care. As of now, none of these data elements exist in any of the big data resources that we have. So that was the reason. And what we did was that we started with a workshop of, I think it was 10 collaborating institutions, and all of them shared their data flows, their existing workflows in terms of what files they use for data extraction, how are they getting their hands on those data elements. We did a comprehensive review of the handbooks and any document that is provided by the vendors, and we extracted the data elements and tried to represent them in OMOP CDM. This is a list of the collaborating institutions that were involved in this effort. And as a use case, in addition to the DICOM standards that exist around this modality, we looked at two different vendors and two different devices provided by two vendors. These are widely used devices, and we just trying to see how well they comply with DICOM and if we're able to get those data elements out from these devices. But we faced several issues that in our path. One of them was the inability for us to do a standardized extraction from each of those devices. Both vendors required the institutions to purchase an additional advanced license to export those files from the devices. And after that step, the files that were presented to the institutions were not necessarily standardized. If if the file was ended in .dcm format, they would call it DICOM, but they were not necessarily standardized DICOM files, and each of them had different data elements in them, so they were not really useful. Even if we look at the conformance statement provided by those vendors, the compliance level to the DICOM standards are varying, and this is a not good area for the vendors, so they don't really comply to the full DICOM standard that we have out there. Another issue that we have was the non-comparable data elements, meaning that because of the differences in the testing algorithms and differences in how those stimuli are being represented, the same concepts measured by different vendors are not necessarily comparable with each other. So we had to have a way to differentiate what device was used for the test. And looking at OMOP CDM, we can see that from test specification, eye level data, trend analysis, point level, and cluster level data, which was a total of 107 data elements. 88 didn't have any matches in OMOP CDM, and only 14 had equivalent matches in OMOP CDM that we were able to use. But then we decided to use the standard file that in this case is OPV DICOM files, because it was the vendors are required to present these files to the institutions, but not all the data elements are necessarily in them. But at least they provide a vendor agnostic way for representing those data. So we decided to use the OPV DICOM files as the standard source files for our mapping effort in here. And we created a list of codes in collaboration in our work group, and we proposed them to LOINC. Those codes closely align with DICOM tags and DICOM data elements, so they can basically being mapped to each other and be used interchangeably. And those codes are still pending approval by LOINC. And then as another step that we took, we designed a package software that basically extracts those data files and converts them in bulk to a very huge pandas data frame, which can then be used for ETL purposes and loading into OMOP CDM data resources. And we internally validated that software package, and the external validation is pending. But just as a closing point, one of the other functions that package does is that it looks for DICOM compliance. And here we got standard sample files from the vendor, and you can see that how the DICOM compliance looks like in different files that we got from them. It's not a very good look, but we're hoping that after presenting these results and communicating these with the vendors, we can get a better compliance on that side. I wanted to thank you all for your attention, and I wanted to thank the Odyssey iCare and Glaucoma subgroup meeting, and a special thanks to Sally Baxter and Michael Boland for their support and supervision throughout this effort. Thank you.